Okay, so start with a simple number like 2. Really? Okay, now what's its inverse? What would you multiply 2 by so that you get 1? 0.5 or a half. 2 times a half is 1. So if I take the term and I multiply it by its inverse, I should get 1. Because that's what a multiplicative inverse does. Okay, so the multiplicative inverse, the notation for it looks like this. All right, what if you had something like, 2/3? Yeah. 3/2 is going to make it 1. So this would be 3/2. All right. 1/5. 5/1. Yeah, when I multiply them, I get 1. So pretty easy. Okay. I. Yeah. I to the -1. Well, think about if we had I. So let's look at it over here. We want to change this. We want to multiply it by some number so that we end up with 1. Okay, now, what power of I is equal to 1? So remember, I to the first is the square root of -1. I to the second is -1. I to the third was equal to the opposite of I. So this was I to the first is simply just I. And then I to the fourth was equal to 1. So what would you need to multiply this by to turn it into 1? Yeah. Excellent. I to the third. And the reason is I times I to the third equals I to the fourth, which is 1. Okay, how about I squared? So let's see, we said this one was I cubed. This would be I squared. If we took those two and we multiplied them, we'd get I to the fourth, which is 1. Okay. What about I to the third? Yeah. I, yep. Because I to the third times I is equal to I to the fourth, which is 1. So those are your reciprocals. Okay, how about I to the 99th? What would be its reciprocal? So what's I to the 99th the same as? Divide it by 4. What's the remainder? Say it again. What's divided by 4 though? 99 divided by 4. Yep, so that's remainder 3. So this would be the same as I to the third. And its reciprocal is I. Okay, so really, I to the 99th times I would be I to the 100th, which is I to the 0, which is 1. All right, any questions on that? Okay, pretty straightforward. Okay, now, if we had, let's say, 2i, yeah, 1/2 I to the third. So let's see. If I had 1/2 I to the third, that would be 2i times 1/2 times I to the third, and that would be 1. Yep. That would be 1 I to the fourth, which is 1. Okay. Now, I to the third, guys, is, remember, I to the third is the exact same thing as negative I. Okay, do you understand why this is? Yes, no? Okay, here's I to the third. And I to the negative 1, I mean, its value right there, that's negative I. I to the third is negative I. So this is going to be my conjugate. My conjugate for this is actually going to be negative 1/2 I. So look, watch here. Negative 1/2 I. That's negative I squared, which is 1. So this is the conjugate. Or not the conjugate, the inverse. Let's do another one here. What if you had negative 7i? Negative 7i. Okay, what's it going to be? I'm sorry? What's the conjugate? So 1 over 7. Okay, and then did you say it was? No. Yeah, which is the same as negative I. So that is Move the negative out front, negative 1/7 I. Okay, so I'm going to erase that and just put negative 1/7 I. Negative 1/7 I. Let's see. Now, if I do that, does it give us positive 1? Yeah. A negative times a negative is positive. And then I got, oh, wait a minute, something's not right. Because this would be I squared, which is negative 1. So that doesn't work. Negative 1/7 I doesn't work because it gives you negative 1. What do you got to change? Yeah, just get rid of that. Which, if you get rid of that, makes it work. Okay, now you would have negative I squared, which is negative 1 times negative 1, which is 1. So you see how you're changing when you're working with an imaginary number, the sign is going to change. Okay, so the answer to this one here was negative 1/2 I. So you notice that there is a sign change. Now that only happened when you had a coefficient there. Okay, you had to change the sign. All right, now we did this the other day in class. If you had a generic complex number that either looked like this or like this, its multiplicative inverse was A, switch the sign, BI, over A squared plus B squared. That's what we came up with. We got that from from the homework on number 6. The problem set that we did, we came up with that formula. And so if it was A minus B, then it's going to be A, switch the sign, over A squared plus B squared. Okay, so now you've got a formula for complex conjugates. Okay, so let's try some more examples here. Okay, term. I said that wrong, guys. I said complex conjugates. I should have said inverses, not complex conjugates. Inverse, multiplicative inverse. All right, so this is going to be that. And then if I multiply these two things out, I should get 1. All right, so now let's try, let's see, 3 plus 4i. Now, what's its inverse? So use the formula up top. Switch the sign. And then the denominator is going to be 3 squared plus 4 squared. So that's 3 minus 4i over 25. And that is your inverse. If you multiply those two terms, you'd get 1. So if I said, hey, prove it to me, prove that that's the inverse. Well, you take your original and you'd multiply it by the conjugate, or not, I keep saying conjugate, inverse. How's that going to equal 1? If I multiply those, the bottom is 25. Okay, what's the top equal to? Well, if you did your little box, 3, 4i, 3 minus 4i, and I filled in my box here, that's 9, negative 12i, 12i, and this would be negative 16i squared. So you see how these cancel, and I've got 9 minus 16. I squared is the same as negative 1, and that would be 25. So the two numbers on the top, guys, that's what is known as a conjugate. So this term and this term are called complex conjugates. Okay, let's see if I can squeeze that in there. Conjugate. 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 Yes, sir. Yeah, go ahead. Okay. Conjugate. T-E. Alrighty. All right, how about 5 minus 3i? Okay, what's its conjugate? Okay, what are we going to get? Numerator. Yep, 5 plus 3i. Okay, denominator. Plus 3 squared. So that would be 5 plus 3i over 25 plus 9, 34. And that's the multiplicative inverse. If we multiplied those two, we'd end up with 1. If we did this is the original times this is equal to 1. All right. Okay, let's make it a little bit more involved now. Let's try, how about 3 plus root 5I? Conjugate. What do you think, Christian? Don't know? Okay, so let's take the top. You're going to rewrite it. Notice the pattern there. So what would the numerator be? Okay, go ahead. 3. Yeah. And now down here, you're going to have 3 squared plus root 5 squared. So I end up with 3 minus root 5I over 9 plus 5, 14. And there's your inverse. If you multiplied those two, they would equal 1. Does that make sense, Christian?
Yeah.
Okay. Yep. 5I times 3 minus root 5I over 14 is 1. All right. What if you had something like root 3 minus I over 9. Now that's a fraction. Okay. Yeah, did somebody say split it? Yep. This would be the same as, so if I split this, I'd have root 3 over 9, I can't do anything with that, minus 1 over 9I. Those are the same. Those are the same thing. All right. Now when you do the conjugate, or the inverse, I keep saying conjugate, I mean inverse. All right, you're going to rewrite the bottom, the complex number, plus 1 over 9I. Okay, remember, these are called conjugates. This and this are called complex conjugates. So the numerators are the conjugate. Okay, now do the denominator. Okay, so you're going to have what? Root 3 over 9 squared plus negative 1/9 squared yeah. Why is there an X? I don't know. It's supposed to be an I. I get so used to X's. Okay, so we got those. There's your complex conjugates. All right, now let's do the denominator here. Let's see. That's going to be 3 over 81 plus 1 over 81 so that gives me 4 over 81. Okay, almost there. I'll come down here because I'm running out of space. So this right here now, when you divide by 4 over 81, guys, that's the same as multiplying by 81 over 4. Dividing by a fraction is the same as multiplying by its reciprocal. Yep, and now you just distribute that. So when I multiply this, 81 over 4 times this, the 81 and the 9s are going to cancel, so I've got this times root 3. That's going to be 9. So this is going to be 9 root 3 over 4 plus, and when I multiply the second one, 1 over 9 times 81 over 4, I get 9 over 4. I. And there's your conjugate. Or, gosh, not conjugate, inverse. Okay. Yes.
Where it says dividing by 4 over 81, which is the same as multiplying loss.
Okay, well, when you learned how to divide fractions, you know, back in the day, like if you had, I don't know, 2/3 divided by 3/4. Well, when you that's the same as 2/3 divided by 3/4. And your teacher probably taught you to, when you divide, you multiply by the reciprocal. So that's the same as 2/3 times 4/3. Why am I dividing? This right here? Right here? Oh, leave it like this? Oh, typically you don't leave fractions in a denominator. So you just rewrite it. So when you're dividing by when you have this is like a complex fraction. So, like if you had 2/3 divided by 3/4, you don't leave it like that. You wouldn't leave a fraction like that. You'd rewrite it as multiplied by the reciprocal, and now you got 8/9. That's how you'd leave it. Yes. Yeah. Does you see what I'm doing there?
Yeah.
Okay. Yeah. So yeah, you wouldn't leave a fraction in the denominator. You just rewrite it as multiplying by the reciprocal. Okay. So what the assignment is, guys, for this, you're going to go to, let's see. You're going to need one more page here. So let's go copy, paste. All right. So on a separate sheet of paper, you don't have to do the homework digitally, okay? You can just do it on a separate sheet of paper. So you're going to do lesson 7 problem set. Problems 1 through 3. Okay, and then over here you got your name, date, or period, date. So don't do it on the paper, do it on a separate sheet. So period, date. Okay, and that assignment looks like this. I'll tell you what page it's on. Classwork, it's right here. So it's on page 27 of your packet. It's this right here. Okay, so you're doing 1, A and B, 2, and 3. 2 is just like we did on our notes today. Just do it on a separate sheet, highlight your answers or circle them. And this is going to be due on Wednesday. So that's 9/1, I think. Let's see. Yeah, 9/1.